All right, so here's kind of where we're at. We have that the derivative of a standalone all by its lonesome constant is going to be equal to 0. And the power rule we are going to use when we have x to a number or a variable to a number in the numerator. And the power rule tells us to bring down the exponent and then subtract 1 from the exponent. So bring down the exponent and then subtract 1 from the exponent. Okay, so now what we're going to talk about is the next rule, which is our constant multiple rule. And the constant multiple rule says that our constant coefficients are just going to tag along for the ride. So what happens here is you have c times f of x inside of the derivative, and what it says is that it's just going to be c times f prime of x. Now, when you talk about constants, there's often a big confusion over constants and exactly what the derivative is going to be. So here is how I think about this. If you have the derivative of a stand-alone, all by its little lonesome constant, so it's all by itself, stand-alone constant, that will be equal to 0. So the derivative of just 3 standing alone, all by its little lonesome, is equal to 0. But if the constant is with something, then it is going to tag along for the ride. So if you have, for example, 3x squared, this 3 is with something, so it just tags along, and we have our 3 still there. And then the derivative of x squared, we would use the power rule for. So we would bring down the 2, and then subtract 1, so 2 minus 1 would give us 1. So this would become 3 times 2, so 6x, and that would be our derivative. So if you have a standalone constant all by its little lonesome, it's going to be equal to 0, and if it's with something, then it's going to tag along for the ride.